All right, so when we're graphing, you're just going to use a whole lot of prior knowledge to graph what we've been graphing all along. So you should already be well aware of what your rules are for inequalities. So I'm really not going over the rules. I'll go over them as we go through here. But if I were you, I would graph different things in different colors because it'd be easier to see the shading. And for some things I'll shade in pencil, some things I won't shade at all, just to shade the intersection. So we'll talk about that as we go along. So what kind of a graph is x equals -1?
Line.
But what kind of line?
It's
It's a vertical line because it goes through the x-axis at -1. So this is a vertical line. Is that line solid or dotted? Solid. Why is it solid?
Because it can.
Because it has a line under the.
Because of the equals to sign. If there's an equals to sign, then it's a solid line. If that equals to mark is missing, it's dotted. So we're going to go ahead and place a point on the x-axis at -1. She was checking for our clock. And so then,
Is that solid or dot?
oh yeah, thanks. That's why I get distracted with the admin coming in. Thank you. So I rewrite things out. All right, so this is x equals -1. And then our shading is less than, so technically our shading is going to go over here to the left. I'm not going to shade on mine, you can shade on yours, because shading with pen makes it a little messy. So if we're shading, to be shading all over here to the left, because that's less than. Then we're going to graph this equation, which is what kind of line? Horizontal line. Is that going to be solid or dotted?
Dotted.
That one's dotted. And so you're going to place a point on the y-axis at 2, and the only way to cut that y-axis is horizontally. And then we're going to dot that line. And you must label each line. So don't forget to label your lines. And then this says greater than 2. So greater than would be above the line. Where would the shadings intersect? Less than and above. Where would those shadings intersect? In that upper left corner, wouldn't it? So I'm just going to shade in that intersection. On Math Excel, you'll have a little paint can, and you'll pour the paint can in where the intersections overlap. I will remind you that this section of your test is by hand. So if you're doing your homework in Math Excel and you're doing it on your calculator, are you going to be prepped for your test? No. So that helped you for your homework, but it didn't really help you for your test. Do you feel better?
A little.
Good. All right, so then I want you to do B on your own. So share your graph with those around you and see if they agree with you. So share where you think the solution is, where shadings intersect, what your lines look like. Check to make sure that the person you're looking at has labeled everything.
Sure, I'll agree.
Brett, I like easy peasy. Absolutely.
There we go.
Yes.
Everybody said absolutely.
All right, here's the solution. Are we ready? That means your mouths are closed. So that's what your solution should look like. Let me point out a couple of things. Thing number one, make sure your lines are labeled. This line right here, anytime, yes?
Can we fill up, like, let's say we do shade the whole top part?
Like you would have shaded this whole
Yeah.
top part, and you would have shaded this whole part, but you've got to make sure that this is really dark. If I cannot tell where it's intersected, meaning that you've made this really dark, or you pointed out here that that's the solution, you've got to do that. Because if I don't know that you know where the intersection is, I can't give you credit for that. Does that make sense? Okay. And also note that if one of your horizontal or vertical lines is one of the axes, it's very hard to tell if the axis is dotted or solid. And so if I can't tell if it's dotted, and notice that I drew mine right underneath it, so you can definitely tell it's dotted, then you might need to put an arrow dotted and write the word dotted on there. So make sure everything's very clear to me. When I'm grading 180 papers, you know, I may or may not see that. If I don't see it, oh well. Yes. You okay?
Yeah.
Okay. So we good to continue. All right, so not everything is linear. Okay. So for this next one, we have a parabola, and I know that we have a parabola because we have an x squared. So all of a sudden, I don't have something linear. So we're going to solve this one for y, and be really careful. When I get y by itself, I start off with a negative y less than or equal to a negative x squared plus 1. What happens when I divide by a negative 1? You have to flip that sign. Anytime you multiply or divide across that inequality for a negative, you must flip the sign. So and that'll affect your shading. And it'll come up in your solution because then you won't get the correct intersected shadings. So we have y is greater than or equal to positive x squared minus 1. And so I'm going to graph this one in blue. And this is the graph of a parabola. And is my line going to be solid or dotted? Solid. Now, if you don't recognize the translation, go all the way back to August when we talked about general functions. Isn't y equals x squared one of our general functions? And weren't the points for that 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4? If you don't know that, then I'll give you a way out.
When you said it.
Okay? So what does this negative 1 outside the function do to it?
Change the sign.
It moves it down. Outside the function moves it down because it's negative. So each one of those points gets moved down 1. And it's a solid line. So I get this. And so I'm going to erase with my oops, I'm going to erase those points that I just put in. Now, if you weren't able to do that because you forget, then you can just plug in values. Are we listening? You can just plug in values for x and get y. So you can plug in 0 for x, square it, you get 0 minus 1 is negative 1. So 0, negative 1 is a point. And you can plug in 1, square it, you get 1, minus 1 is 0, you get a point. 1, 0. And then negative 1 will give you that same point. The problem with doing that is you must be able to capture your vertex. And so if you don't have your vertex, you're going to miss points because you didn't show where the proper vertex was. And so for those of you who have trouble with your translations, I would make sure that you know that, and where am I going to put that? I'll put that way down here. So the x value of the vertex of a parabola is equal to the opposite of b over 2a. So if you didn't know that, remember that a is the coefficient of the square term, b is the coefficient of the x term, and I'm missing the x term here, so what's my b? 0. And my a is 1. Your constant is always c. And so here I would be putting in the opposite of 0 over 2 times 1. Well, 0 over 2 is 0. So the x value of my vertex is 0, sure enough. Then you'd plug 0 into the function to find y. So you would capture your vertex that way. And then you can make decisions as to how you want to choose points from there, because you always want to choose some points to the right of that vertex and to the left. So you're going to practice that on Math Excel. So again, if you're using your calculator, you're not going to be able to practice that. So be careful. Okay, then this other one, right here, we're going to solve that for y, and that's easy enough to solve for y. Y is greater than or equal to, less than or equal to, add a y to, or add, I can't even talk today, add an x to both sides, plus 1. I'm going to graph this one in red. So what kind of line is that? Linear versus a parabola, right? Solid or dotted? Solid. So when we look at lines in y equals mx plus b form, if I were you, I would be writing out what is b? What's the y-intercept? 1. What's the slope? What's the coefficient of x? 1. You want to write that slope as a fraction, 1 over 1, or negative 1 over negative 1. Both of those give you a value of 1. So that's going to help you stair-step your slope. So plot 1 on the y-axis. And then stair-step, a positive means up and to the right. Rise up, go to the right. So we're going to go up 1 to the right 1. Up 1 to the right 1, and that's where the parabola and the line intersect. Up 1 to the right 1. Or down 1 to the left 1, another intersection. Down 1 to the left 1. And so forth. And we're going to connect that with a solid line. So here's where it gets tricky. The parabola, if you look at the new formula for the parabola right here, when we change that sign, says y is greater than. So the shading for the parabola is greater than. Does that mean the shading is inside the parabola or outside the parabola? Inside the parabola would be from this borderline, inside the only way to go above this borderline is to go from that line up, isn't it? So inside would be the shading for greater than. Outside would have been the shading for less than. So this is the shading for the parabola, right there. Then for your line, it says less than. So this is your line. Less than means that's where things are buried. In other words, this is a mountain. Do you bury things on the upper left or the lower right? Emphasis on lower right? Correct? So this is where you would bury things, in case you ever needed to know that. Where do the shadings intersect? This little J curve in here, right? This is the intersection right here of the shadings. So that right there is the solution. Then I want you to do B. Well, we'll do B sort of together. I guess you could do B on your own. I'll do it quietly up here, but you got 3 of them. You've got 3 of them, so at least graph them. Then we'll talk about the shadings. What? What about it? I'm doing it quietly up here, not on freeze. Okay, so when you get to this point, we'll talk about the shadings. Bless you. Just because the three lines form a figure, in this case a triangle, does not mean that the intersection of the shadings is always the triangle. So be really, really careful with that, because in this case it ends up being the triangle, but in some cases it could be just this part. Well, it wouldn't be in this case, because it has to be where all three intersect. It could be there. It actually could be over here, depending upon how the inequalities are. It could be over here, it could be over here. I mean, it just depends. So let's look at the shadings. So for the blue line, which is the linear line that has a slope of 1, it says y is greater than. So is that above the line or below the line? Above or below? Above or below? Above. So your shading for the blue line should be here. I only heard one person answer. Just saying. I know, but it's just one person. I wanted all of you to answer it. That's why I kept saying. If I'm asking, I expect all. All right, so the red line here is greater than. Is greater than to the left or to the right? It's to the right. So then here's where that shading would be. So far, the intersection of those two shadings is right here between the red and blue lines. And then the third line, the green line, is less than. So is that above or below? Below. Below. So then these shadings go in this direction, and then you can kind of see where all three shadings intersect, and that's right here in the triangle. And so this is indeed your solution.
Do we get colored pencils on?
You don't get colored pencils, but you can bring colored pencils. I will not provide them for you. But for some of you, that makes you happy. All right, so that's just kind of a review of graphing inequalities. You've had these before. All right, so that's why I expect you to be able to do them by hand. So let's flip. What we haven't talked about is what happens if there's no solution or infinitely many solutions, that kind of thing. Shh. So you're going to solve this first equation for y. So we get 3y is less than negative 2x plus 6. And divide by 3. We don't flip the sign, I didn't divide by a negative. So I get y is less than negative 2/3 x plus 2. What kind of a line or what kind of a graph is this? Oh, it's a line. So this is linear, solid or dotted? Dotted. What is b? 2 and m. So take that negative and you can put it in the numerator, or you can take the negative and put it in the denominator. You have to be able to stair step in both directions. So we're going to start on the y-axis at 2, and we're going to go down 2 to the right 3. You always go up or down first, and then right or left. So down 2 to the right 3. Or you can go up 2, but to the left. And so label this y equals negative 2/3 x plus 2. Bless you. And on this one, it says less than, so is your shading above and to the right or below and to the left? Right or left? Help. Well, technically, this is a line y equals 2. It's the shading that creates that less than part. So technically, when you're labeling lines, it should be an equals 2. If you label it with an inequality sign, I'm not going to mark you off for that. So the shading for this one should be down here. Okay, and then we're going to graph this one, but before I graph it, we have to solve. It's very similar. 3y is greater than negative 2x minus 6. So when I divide by 3, I don't exactly get the same equation. I get y is greater than negative 2/3 x minus 2. So this is also linear. Is it solid or dotted? Dotted. What's b? So this time it's negative 2. And then m is the same. So what does that tell you? The lines are parallel. That does not mean that we have no solution, by the way. It depends on your shadings. You could have no solution, but you could also have a solution. So I'm going to start at negative 2. And I'm going to go up 2, but to the left 3. Or down 2 to the right 3. And this one is greater than, so it's a shading right or left?
Right.
Right, and so this one goes up this way, and you can see the intersection of the shadings. Again, don't leave that intersection up to me to determine. You better darken it really dark, or draw an arrow to where that intersection is. So this is where the intersection is, so there actually is a solution with parallel lines, and there's the solution.
Did you want us to shade, like, for each side of, like, for each equation, did you want us to shade the full side of what it is? Or
It'd be
can we just shade
nice.
the
You can
solution?
just shade the solution, but the problem is, if you shade the solution and it's wrong, you get no credit for this shading, that shading, or the solution. You get no credit for those. So if you're just going to shade the intersection like I did here, and let's say that the intersection really was over here, you lose 3 points rather than 1, let's say. So it's to your advantage to do all the shading for partial credit purposes. All right, so I want you to do B on your own. So I want you to share your solution with those around you.
That's you subtract off of that and the excess amount, that's how you switch it. It can't be like 3 minus x.
So discuss the solution.
Yeah.
I'm probably.
How long have you been?
Will be negative x minus.
How long have you been this year?
There's been
Long
some
enough.
there's been
You're doing pretty well. Long enough to not be for myself.
true.
Do we
So look
need
up
all
here.
of the b equals and m equals to your credit?
No. Alright, so look up here. Where's the intersection of the shading? So therefore, what's the solution? You must physically write the words "no solution."
Can I write it in between the 2 lines?
I don't know that there's no solution, that you know that there's no solution if you don't tell me. What was your question?
If I could write it in between the lines.
You could. Thank you.
Yep.
Hannah? Alright, so then the only other thing that we haven't covered is circles. And we've done circles before. I just chose not to give you an example that had circles. And I don't know what happened to my blue pen. It disappeared on me. So for Math Excel, you might want to write this up here. The standard equation of a circle, if you'll recall, is x minus h squared plus y minus k squared equals r squared, where the center is equal to hk, so you change the signs, whatever the signs are here, you change them and that becomes your center. If nothing is being added or subtracted to the x and the y and it's just plain x squared or plain y squared, then your h or your k is 0. And then your radius is equal to r. So you'd have to take the square root of this over here. So if the equation has both an x squared and a y squared, then you need to make sure it's in standard form before you graph it. So I'm going to give you an example of what that looks like, and then I'll make sure that I post these on the notes online. So can I show the examples? Okay. So here's the circle one. So you're given just this equation, and it's just less than or equal to 16. So it is in standard form because it's x squared and y squared on the left, and the 16 is on the right. What is being added to the x and the y? Nothing. So that's why the center is 0, 0. The square root of 16 is 4. That's why our radius is 4. I'm going to have a solid line for my circle because it's equals to. If that equals to were missing, your circle would have a dotted line. So you always plot that center first, and then you go north your radius, so north 4, south 4, east 4, west 4. And then I used compass to draw that circle beautifully, just saying. And so that's how I got my circle. Now, because I certainly didn't hand draw it, because it says less than, the shading goes less than from all parts of that line of the circle. So that's why the inside of the circle is the solution when it says less than. If it said greater than, then it'd look like a sunburst. The outside around that circle would have been the solution. Okay? Then I wanted to show you a parabola that opens right or left. Recall that that's y squared. So if you have a y squared, you're going to want to solve the equation, and again, I'll have this online, so you get the y squared by itself, because for these ones you can put in your calculator if you like to, just so you can check it. But if you get the y squared by itself, take care of, in this case, it's got a negative y squared, so take care of that by dividing by the negative. That meant that we had to flip the sign. When you solve for y you have to take the square root of both sides, we have to do plus or minus. So you get y is less than the square root of x, and you end up with y being greater than negative square root of x, and you'll see why in a minute. If I graph this part here, it looks like that. And if I graph negative square root of x, we're going to be down here below the x-axis. So I can't have, if this one's less than the original one was less than, then the other one has to flip and be greater than. Because I can't have less than here and then less than out here. That would be the whole parabola, right? So you end up flipping that sign when you do the greater than or less than. I won't be testing you on this. I'm just showing this to you if you encounter it in Math Excel. And so I will have those online for you to look at. But for now, let's look at the linear programming. If you would, please change this 10 to read 14. There was a typo, and it looks a little weird if you don't switch them. So the 10 should read 14, and the 14 should read 10. So your job on these linear programming questions are going to be to find the maximum and the minimum values of this function here. We use the function at the very end. So we're going to start off by, and oh, by the way, you might want to write on here that you may use your calculator for this example. Okay, and you'll need to use your calculator on Math Excel for this example because some of the ordered pairs get quite large numbers. And you're going to need to use the intersection to find some intersections here. And again, it's easier on your calculator. So this will be on the calculator portion of your test. So, first thing I want to do in order to use my calculator is to input this in, have this in a form that I could input it into my calculator. So I'm going to solve this top equation for y. So I get 3y is less than or equal to negative 2x plus 14. Divide everything by 3. And so I end up with y less than or equal to negative 2/3 x plus 14/3. Pretty ugly to have to graph, but we'll deal with graphing that in a moment. And then this one, put into our calculator, we're just going to simply solve for y. And so we get y is less than or equal to negative 2x plus 10. And then I don't have to solve the other two. So I would like you to graph this on your own. What's the highest y-intercept that we're going to end up with out of these four? 10. So I want my grid to go up to 10. So we're just going to sketch it. Good gracious, that was scary. Did it hurt? Do you know that people used to come to Phoenix to get away from allergies?
Used to.
Well, then you develop more allergies being here. Okay, so let's graph what we have. I'm going to graph this first equation right here. Now, instead of graphing a y-intercept of 14/3 and trying to stair-step a negative 2/3, here's what I would suggest. If you get something funky like this, go back to the original equation and use x and y intercepts. If I let x equal 0, what would y be? Solve for y. If I let x equal 0, x is 0, what would y be? 14/3. What is that as a mixed number? 14/3.
3, 6, 3, 5,
4 and 2/3. Wow. So 4 and 2/3 would be right about here. Right? That's 4 and 2/3, that's my y-intercept. And then if I let y equal 0, what is x gonna be? That one's easy.
0.
No, solve for x.
What'd you say?
I'm letting y equal 0, what's x gonna be? Solve for x. 2x equals 7, or 14. 2x equals 14.
Oh.
7. I'm letting y equals 0, so that disappears. That's why I'm covering it up. And all you see is 2x equals 14. What is x? 7, right? So x is 7. So then we can connect these 2 points, and that would be an easy way of graphing by hand. The first one I let x equals 0, so that goes away, and then you solve for y. So that was 14/3, which was 4 and 2/3. Okay? Plus you can see that in the slope-intercept form of the line over here. Okay. All right, then we're going to graph this line in, let's graph it in pink. All right, so that one's easy enough to graph, isn't it? We could use x and y intercepts if you want to. If I let y equal 0, what's x going to be? 5. So we plot a point at 5 on the x-axis. If I let x equal 0, what's y going to be? 10. So plot a point on the y-axis at 10. And an intersection is created between the two lines. This right here is called a critical point. We will find that critical point later. That's what your calculator is going to be handy for. And then we have x is equal to 0. Isn't that the y-axis? This is where all x values are 0, so that's the y-axis. So I'm going to draw that in green. Well, hard to see, but I drew that well. I'll draw it to the side. There's my green. Okay. Then I think I'll do this one in red. And this is going to be the x-axis. So I'm going to draw the x-axis in red. So what happens is these 4 lines have created a quadrilateral here, here, and here. Those are your critical points. We're going to find those critical points in a moment. You can easily tell what 3 of them are. This is the one that's harder. So we're going to go ahead and graph on our calculator. So let me get the glare off my calculator. All right, so we're gonna, bless you. We're gonna put these lines into our calculator. You must use parentheses for the -2/3 and the 14/3. So parentheses, -2 divided by 3, and parentheses, x, plus parentheses, 14 divided by 3. If you don't use parentheses, it's not gonna graph it correctly. Then on top of that, we can talk about our shadings. This is less than, isn't it? So go scroll to the left until you see that diagonal bar. See how the diagonal bar is flipping up and down? Scroll with your left key until you get that diagonal bar flipping up and down. And then you can just hit enter, and it changes it all of a sudden to a thicker line. Now it changes it to a shaded line above, so it's telling you it's going to shade above. What do we want our line to do? Shade below. So click it one more time and there's a shading below. And there's also a dotted feature on there as well. So then scroll down and to the right of the equal sign, and we're going to put in the next equation, -2x plus 10. Again, scroll to the left. What do you want that to read? So hit enter, enter, what, 2 or 3 times, whatever it was. So now it's showing that it's shaded below. Scroll down and to the right of the equal sign. Can I input x equals 0 in here? Nope. But I can do y equals 0, so I can just put in a 0 there. And I want that to be shading where? Above. So enter twice. Okay? So then when you graph it, you can see the shading occurring. There's the first line. love it. And if you have a color calculator, it's even more fantastic. And then there's the other one. So that you can see this little quadrilateral in there, but I want it to blow that up. So I want to adjust my window. So go to your window, and our X min doesn't go in the negatives. So you can make your X min 0, your X max, we can make it, I don't know, let's make it at 6. No, I want it bigger. I want to be able to see. You could do 8, but it doesn't matter. And then your Y min, make 0. Your Y max, we don't want to make 10. I'd make like 12, because your max is 10 on that Y axis. And then hit graph. And so you see it going all over again. And so, what we want to find out is this intersection here. So sometimes it's easier to find the intersection if you take away some of those lines and the shadings. Yes? On your window, your Y, we did 0 and 12. So let's go in here and take away, I have right over here the pink line and the blue line that I really am interested in the intersection, right? So if you want to, you can take away the shading by hitting enter until you get back to the normal line again. And I can go down below and do the same thing. Because I don't want to see the shading, it interferes with what I'm doing. And then I'm going to take this one away altogether. Clear that one out. I don't want that one in there. So that now I'm looking at this graph here. I got rid of all the excess. And I only care about where those two lines intersect. Okay? How do I do that? Second calc, what do I select? Select intersect. So I'm going to press 5. Ladies, you should be writing this down or doing it on your calculator instead of socializing.
We're looking at his calculator.
No, you're looking at your own that's in front of you. This is not a group calculator problem. All right, so it's saying first curve, and yes, that'll work for me for the first curve. I like to move it just a little closer, I suppose, but you're responsible for what you miss. You've missed a lot today. And then go to your second curve. What time is it anyway?
I don't know.
6. And then hit enter again to guess. And it gives you an intersection of what? 4, 2. So that's a critical point. So over here on your picture, you're going to put 4, 2. Then the other ones, if you look at the shading, this shading was less than, this shading was less than, and these two were both greater than. So wouldn't you agree that this right here is the intersection of all 4 shadings? True or false?
Sure.
So it makes this lovely little quadrilateral. That's what our focus is, and we want the vertices of all points of that quadrilateral. So this vertex right here is 0, 14 thirds. Where did I get the 14 thirds from? Wasn't that my y-intercept of the blue line? Right? And then this point right here is the origin, 0, 0. What's this point here? This point here? 5, 0. And so those are critical values. So the following is going to occur. Now we're ready to start. All of this was step 1. Yep. So all of that, this was step 1. Then your step 2, the rest goes fairly quickly. We're going to use the function f is equal to 5x plus 8y. This is going to be our focus. Then we have what are called constraints. Step 3. Your constraints were the lines that you just drew. And so your constraints, and we're going to use the original, are 2x plus 3y is less than or equal to 14. 2x plus y is less than or equal to 10. X is greater than or equal to 0, and y is greater than or equal to 0. Those are your constraints. And then step 4, we're ready to analyze. Because remember, we're supposed to be finding the max and minimum values. And the max and minimum values, this may not be necessarily be the maximum value just because it's the highest. It depends on what the figure looks like. So we're going to take the function 5 times x plus 8 times y, and we're going to come out with values. And we're going to use each of our critical points. So let's write out those critical points. Here. So let's do our critical points. So those critical points, let's list them. We had 0, 14 thirds. We had 0, 0, 5, 0, and 4, 2. So we're going to use all of these in our analysis. So start with your first point. We're going to plug in our x value is 0, our y value is 14 over 3. So use your calculator. We know what 5 times 0 is. Then 8 times 14 divided by 3. That's 37 and what? 1/3. So that's 37 and 1/3. And then do it again. 5 times x plus 8 times y. But use the next ordered pair. So the next ordered pair is 0, 0. And that gives you a value of 0, right? And then we have 5, 0. What does that give you? 5 times 5 is 25, because 8 times 0 is 0. And then our last one, we're plugging in 4 and 2. So this gives me 20, and that's 16. What's 20 plus 16? 36. So, what is your maximum? So this is our max, and then what's our minimum?
0.
There. So now we can answer the question. So finally, step 5, therefore, the maximum value is 0, 14 thirds, and the minimum value is 0, 0.